Okay, now we're going to review equations of tangents and normals. And if you guys remember, there's always two things that we need. One of those things is a point. Sometimes you're given the point, x and y, the whole thing, and you don't have to worry about it. Other times you're given just x equals some number, so that's the x value of the point, and you have to find the y by plugging into the original. You always find y by plugging into the original. Sometimes this will come in handy in other types of problems as well. The second thing you need is slope, and you get this by taking the derivative and plugging in x. Or if you're in implicit differentiation, then you have to plug in both the x and the y. But either way, you're taking the derivative and plugging in to get that slope. From there, once you have those things, you'll be using point-slope form of a line. And that's when we do y minus something blank equals blank and x minus blank. And when you're plugging in, the y value of your point from up here is what goes in here. The x value goes with the x, and then the slope that you found using the derivative is what goes in front. And for a free response question, if it just asks you for the equation of the tangent line, you can leave it in this form. Occasionally with multiple choice questions, you'll need to solve it for y and get it into slope-intercept form, y equals mx plus b. Okay, so now I'm going to do a basic example with you. And this example says, find the equation of the tangent line to the graph of y equals cosine x plus tangent 2x at the point 0, 1. So we're really lucky in this one that they gave us the whole point, the x and the y. We don't have to plug in to find y. But if they had just given us the 0, we would plug 0 in here and 0 in here and solve that out and get our 1. Since they gave us the point, we can move on and get the slope by taking the derivative. So the derivative of cosine is negative sine, and the derivative of tangent is secant squared. And this has to be a chain rule because you have the 2x, so we're going to multiply it by 2. Now I'm going to plug in my point, and this derivative just has x's, so we just plug in the 0. So negative sine of 0 plus secant squared of 2 times 0 times 2. And then to figure these out, you'll have to remember on your unit circle, at 0, the point is 1, 0. So the cosine is 1 and the sine is 0. And since the sine is 0, this is 0. Since the cosine of 0 is 1, and this is the secant of 0, secant would be 1 over the cosine, and 1 over 1 is 1. Then 1 squared is 1. So 1 times 2 would give us 2, making our whole slope for this 2. And now I'm ready to give you the equation. So y minus equals x minus, and I'm going to plug in my newfound information. The y value from the point is 1, the x value is 0, and plug my slope in of 2 in front. If I'm on a free response, this is good enough. If I'm in a multiple choice situation, I want to go ahead and distribute and combine like terms, get it into y equals mx plus b form. So I'm going to add the 1. So 2x plus 1 would be our equation of the tangent line. Okay, so now I'm going to change this problem, the directions, and say that we're wanting the normal line instead of the tangent line. And if that's the case, what is the difference? Well, a normal line is perpendicular to a tangent line, and so I want a perpendicular slope. And the perpendicular slope would be the flip and change of the slope we already have. Since it's 2, if I flip it, I get 1/2. Since it was positive, now I'm going to be negative. So we're always going to have the opposite sign on those, and I'll talk about that graphically in just a moment. But once I find that slope, everything else was the same. I had y minus my y and x minus my x when I plug in over here, but my slope is now going to be negative 1/2. And again, I could leave it like this on a free response situation or solve it out and get it into slope-intercept form if that was better for me. But I do want you to notice the difference between tangent and normal equation-wise. It's not a whole lot. You just have to make sure you're getting that perpendicular slope. Okay, before we move on, I want to talk graphically about what's going on. Let's just say we had this graph f of x, and I've not even put x and y axis up here because you just need to understand the concept here. If I add a line in, let's say we want to be tangent right here at this point. My tangent line is going to look something like this. This blue line that I've drawn in, it's tangent to that point. It's only touching it at that point. Now, we need to think about what the normal line would do. And so I'm going to add a normal line in here. Let me work on that for just a second. All right, so this would be a good normal line. And so what's going on is that they're perpendicular. If you've looked at your geometry stuff, perpendicular lines, you know, have a 90-degree angle right here. And when you learned it back in algebra, that's where we talked about the slopes being a flip and change of each other. So that was the relationship I was discussing with you a minute ago. But this is graphically what's going on. Now, they both go through that same exact point right here. And that is why we can use that point in both equations when we're writing in and filling in our point slope form. It's just that the slopes will be slightly different. One should be positive and one should be negative. Or if they're straight vertical and horizontal, you would have a zero slope and an undefined slope. But any slanted case, one should be positive, one should be negative, but they go through that same point. For our last example, I wanted to do something that was a little bit more complicated because they may throw something at you that's not just straightforward find this tangent line. This one has a little bit more work to it and is going to incorporate another idea. And if you read the question, find the equation of the tangent line to y equals x cubed minus 6x squared at its point of inflection, you'll notice that they're not giving us the x and the y or the x this time. And what they're expecting us to do is to remember how to get a point of inflection. And that is by finding where the second derivative changes sign. And we'll need to do a number line to make sure that that happens. So I need to get my first derivative, which would be 3x squared minus 12x. Then my second derivative, which would be 6x minus 12. Set that equal to 0 and solve. So I'm going to add the 12, divide by 6. I get x equals 2. Then I'm going to do my little number line and make sure it changes sign, because if it doesn't, if it is positive, positive, or negative, negative, it's not a point of inflection. It's possibly something else is going on there. You're not changing concavity, and by definition, a point of inflection has to change concavity. So where do I plug in? You plug in to your second derivative. So if I plug in 0, 6 times 0, 0, minus 12, is negative. Plug in something on the other side of 2, like 3. 6 times 3 is 18, minus 12, going to be positive. So since we do change signs, you know that you have a point of inflection at 2. So far we know that our x value is 2. I now need a y value, and where do we get that from? By plugging into the original. So I'm going to plug in the 2 for x. So 2 cubed minus 6 times 2 squared. And so 2 cubed is 8, and 6 times 4 is 24. And I'm going to get a negative 16. So my y value is now negative 16. I also need a slope, because all I've done so far is get a point. If you go back to the original screen, we get our slope from plugging into the derivative. So I'm going to take my derivative and plug into, because I don't have any y's, it's all x's. So I would have 3 times 2 squared minus 12 times 2. And this would be 3 times 4, which will be 12, minus 24. So that would be negative 12. And so this is my slope. Go to write my equation in point slope form. Plug in the y value of my point, the x value of my point, and my slope. And I'll go ahead and solve this out as well. Again, this is fine for free response. So y plus 16 equals negative 12x plus 24. And then subtract my 16, I get negative 12x plus 8. And so this is my final answer, the equation of my tangent line.